Hello, everyone, and welcome back to Math Zone African Motives. Today, I want us to look into physical sciences for grade 11s, and I've decided that we should actually get to look into more practice questions for the topic forces and Newton's laws. I saw from the comments that there were people who were asking us to dive deeper and do more practice questions on this topic, which is forces and Newton's laws. So, this is what I want us to start. So, what we are going to do is we are going to do a series of videos where I'm going to bring questions from past exam question papers, and then we answer those questions together so that we might have exposure and practice towards this question. Because when it comes to these questions, in most cases, you would actually get application questions that needs you to apply what you have learned more than retention questions. So it is easier and better for us to do as much questions as we can get so that we can get practice and get started. So without wasting time, let's look into the first question that I brought. So this question, I took it from a past question paper. I just took one of the questions from a past question paper just for practice sake. So it is saying a man tries to move a block, but the block is not moving. Which one of the following statements best explains why the block will not move? So you can see that this was a multiple choice question, and you were supposed to choose from these four options which one best suits the scenario that you are given. So I've realized that most of you guys, when it comes to multiple choice questions, you just do guesswork. You don't actually put some reasoning in it. You just do, well, my mother told me to choose this one, but I would like to choose, and you just get to do some guesswork, which is not exactly how you're supposed to be approaching these questions. So the easier way is to look at the scenario and try to remember what kind of laws are they trying to test? Which concepts do they want me to know? Do they want me to retain? So you can see that this is all about what? Forces and Newton's laws. That is what best describes this scenario. So now let's look once again at the question, and then let's look into the options, and let's start reasoning towards the question, and we get to choose which best suits the scenario. So here they are telling us that this man is trying to apply a certain force. So we are saying a man tries to move a block, but the block is not moving. What might be causing this block not to move? So what we know is when it comes to the movement of an object, this is more described with Newton's first law, which is the law of inertia, where we are saying that all objects, they have got that reluctance to what? To change their state of motion, which might be due to their mass, or else which might also be due to the surface in which they are placed on. If we are having friction here, definitely that friction would actually get to act in opposing that force of motion. So let's look at our options. They are saying that A, the force the man exerts on the block is greater than the force the block exerts on the man. If we are having two forces acting on an object, we would simply know that whenever one of these two forces is greater than the other, as we look into the vector sum of these forces, we are going to have what we refer to as the resultant net force. That resultant net force will lead to some acceleration of an object due to Newton's second law. So whenever we have got a force between these two forces being greater than the other, then definitely there will be some movement. But however, here we are saying that there is no movement. So this is definitely out. This is definitely out. Because if the force that the man was exerting on the block was greater than the force that the block is exerting on the man, then this block would actually start to accelerate due to Newton's second law. So this is actually out because we want to examine why the block is not moving. This would lead to the block moving because there will be some net resultant force. Let's go to option B. The force the man exerts on the block is smaller than the force the block exerts on the man. If the force that the block is exerting on the man is greater than the force that the man is exerting on the block, then at some point in time, you would see this man also moving in that direction, which is not the scenario here. So that does not best explain this scenario. So this is also out. So at some point in time, we are saying that here we have got balanced forces. We have got balanced forces, so the net resultant force is equal to 0. That's the explanation that we are looking for. So we are saying the force of friction exerts on the force of friction, or else the force friction exerts on the block is greater than the force the man exerts on the block. That is not true if we are having frictional force here. And if the frictional force is greater than the force exerted or applied on the block would move in that direction because there will be acceleration, because there is net resultant force. Your net resultant force here will not be equal to 0. Hence, therefore, there will be some acceleration, which is not true for this scenario. We want the scenario where our net resultant force is 0. So here we are saying the resultant force acting on the block is 0. This is actually our our answer. So you were just going to choose your option D there. So what I was just trying to teach you is when you are approaching multiple choice questions, do not use guesswork. Try to reason in accordance with the scenario that is given, remembering and trying to actually get back all the laws that you have learned, all the concept that you have learned, to try and see which concept or which law best describes the scenario that is given. So our answer here was going to be D. Now, I want us to move on to structured questions. So here I brought a question also from the same question paper. This was now question number 3. And you can see that this question was a structured question where they ask you to give your answer in your own words as well as in your own calculations. They don't give you guided questions. So let's look at question number 3. The question is saying a 0.1 kg Newton scale, I'm sure this is the Newton scale, is connected to a 5 kg wooden block, and this is the block as shown in the diagram below. When the block moves at a constant velocity across a horizontal surface, the reading on the scale becomes 3.42 newtons. So they are simply telling us that there is some applied force on this block. This is the reason why there is a reading of 3.42 newtons. So the force that is acting towards that direction, which is the direction of the what? Of the scale, is equivalent to 3.42 newtons. But however, they've told us that here the block is moving at constant velocity. What does that mean? It means that our acceleration is 0. Whenever an object moves at constant speed or constant velocity, just know that there is no acceleration, because acceleration is the rate of change of speed or rate of change of what? Of velocity. So whenever there is no that change, then the acceleration is equal to 0. When acceleration is equal to 0, according to Newton's second law, we know that our net resultant force will also be equal to what? Will also be equal to 0. Now, let's look at the questions here. They are saying state Newton's first law of motion. So Newton's first law of motion, it states that an object will remain at its state of rest or constant motion unless a net resultant force X on it. X on it. So this is what we're just going to say. That in Newton's first law, which is also known as the what? As the law of inertia. It is also known as the law of inertia, where we are saying that objects, they've got a tendency of what? Of resisting any change to their state of motion. So that is why Newton said that an object will remain at its state of rest or constant motion unless a net resultant force acts on it. Given that, now they are saying, is frictional force acting on the block or else not? So here they want you to determine if there is frictional force acting on the block or not. So since this object will actually remain at its constant velocity, it simply means that this force, this applied force in that direction is being balanced by an opposing force. And that opposing force can be none other than a what? A frictional force. So yes, there is what? Frictional force acting on that object. So allow me to rub here so that you can actually get to what? To follow through what I'm saying. If you actually want to write notes, you can pause the video or rewind and go back. So here the question is there frictional force acting on the block? Yes or no? And the answer is yes. Why? Because we are saying on our block, there is a force applied which is in that direction. That they are saying it's equivalent to 3.4 newtons due to the reading on this scale. Now, if that is the case, they are telling us that this object, however, is moving at a constant velocity. And we say that constant velocity means that acceleration is equal to zero. And acceleration equal to zero means that our net force is equal to zero. Therefore, the sum or vector sum of forces is equal to zero. So this applied force has to have its balancing force in the opposite direction so that the net resultant force here becomes zero. And that can be none other than the what? The frictional force. So yes, there is frictional force acting on the body, which is the force that is resisting the what? The change of motion. So here there is frictional force. That is the reason why the object will remain at its what? At its constant velocity. Now they are saying explain your answer to 3.2 by referring to the Newton's first law of motion. So like I've been explaining here, we are saying that an object will remain at its state of rest unless a net resultant force acts upon it. So here the net resultant force is equal to zero. So how would you have explained this? Let me take time to push this upward and explain here. So 3.3, you would have said that the object moves at constant velocity, comma, therefore acceleration is equals to zero. If acceleration is equals to zero, net resultant force is also equal to zero. Now, since F net is equals to zero, then the object will remain at constant state of motion. That is what Newton's first law states. But however, does it get to explain why we are saying there is frictional force? Yes, because we are saying that if net force is equal to zero, then there should be a balancing force on what? On the applied force, so that this can be equal to zero. So you would come and say, therefore, there is a balancing force. There is a balancing force of friction on the applied force. Or else you can actually simply state that, therefore, there is an opposing force of motion acting on that block. You can actually say, therefore, there is an opposing force of motion balancing the applied force. That is simply what you would have said there. You are explaining in terms of the fact that the object moves at constant velocity. Once the object moves at constant velocity, its acceleration is equal to zero. Once the acceleration is equal to zero, F net, the net resultant force, is equal to zero. Therefore, we are saying that for F net to be equal to zero, when we have got an applied force on that object, there should be an opposing force of motion. That opposing force of motion is what we are saying is the frictional force. That is what we are saying. There is an opposing force of what? Of motion balancing the applied force. That is simply what we are saying. Because the net force is equal to what? To zero. Therefore, there should be an opposing what? Force of motion. That is the frictional force. Now they are saying draw a free body diagram and identify all the forces acting on the block, acting on this block. We say that we have got an applied force in that direction. We have a frictional force in that direction. Due to this mass, we are going to have the weight of the object going downwards. And due to this surface, we are going to have a normal perpendicular force acting on that object, which is normal. So when we are drawing a free body diagram, we remove this object and we represent it by a dot. That's what we mean by a free body diagram. So I'll draw that free body diagram here. So we represent our body or our object with a dot, and then our forces with vector arrows. So we are going to have force applied, and then we are going to have frictional force. So my arrows would actually necessarily be almost equal in magnitude between force applied and frictional forces. Why? Because these two forces are balanced. So I need the length of these arrows to represent my what? My magnitude of these forces. And then I would also have my normal force. I would also have my normal force acting on that object, which is due to the surface, and also my weight, which is also due to that surface. And also these two, they have to have the same magnitude in terms of arrows, because this object is not moving down or upwards. So these two, they are balanced. So this is how you simply draw a free body diagram. And this is just 4 simple marks. All you need to know, be able to identify all the forces acting on the object and be able to represent them in terms of vector arrows, and also represent your object with a dot. That is a free body diagram. After we've said that, now let's look at our what? At our final question. So this one is saying calculate the magnitude of the coefficient of the frictional force for the block. So for this one, allow me to just get to rub here. So they want us to calculate the what? The coefficient of friction, or the coefficient of frictional force that is actually acting upon that object. So we all know that frictional force, our frictional force, is actually given by what? By the coefficient of friction times the normal force. The coefficient of friction times the normal force. So now, we are saying the frictional force is equal to the what? To the force applied, because these two are balanced. Therefore, this is equal to 3.42 newtons, which is coming from the what? The reading of the scale, which is coming from the reading of the scale. And then thereafter, we are also saying that the normal force is equal to the weight of the object, and the weight of the object is equal to the mass times the gravitational acceleration. Now the mass of the object, they said it's 5 kg, and we know that the gravitational acceleration is 9.8 newtons per square second. So here we now have got what? We now have got 3.42 newtons being equal to the coefficient of friction times 5 times 9.8. Given that what we just need to do now is to make mu, which is the coefficient of friction, the subject of the formula there. So I would divide throughout by this. So if I divide throughout, I would cancel out this side. I'll be left with 3.42 newtons divided by 5 times 9.8 this side. While with this side, I said 5.98 divided by 5.98. Now I'm now saying 5.98. Pardon me there. I want to say 5 times 9.8 divided by 5 times 9.98. I'll just divide by 5.98 throughout so that I can get the coefficient of what? The coefficient of friction. So all we now need to do is to actually calculate what is 3.42 divided by 5 times 9.8. So we can use our calculators there to calculate the coefficient of friction. So from my calculator, I'm getting a coefficient of friction which is equivalent to 0.0697. So I can say 0.0698 because it's 79. So this was going to be the coefficient of friction. This is simply how you calculate it. So these were the two questions that I wanted us to look at, and these were the two questions that I wanted us to use for our practice as well as recap. So thank you so much, guys. Let's meet in our next video where I'm also going to bring also two questions, or else three, which would be one from the multiple choice questions, one from the what? From the structured questions. Thank you.